Buenos dias, welcome to this lesson on resultant forces. So to start with, I'd like you to put date title and do the starter, and then I will go through the answers to the starter. Okay, pause the video for a moment while you do that. Okay, so if we're looking at the forces on the ball, we've got two forces now acting. The weight is acting downwards, and we've got air resistance acting in the opposite direction to the direction in which it's travelling. You'll note that there is no longer any forward force. As soon as the ball's left his foot, there is no more force pushing it forward. So what's going to happen? The ball's going to start to decelerate, and then it's going to accelerate downwards because the forces acting on it are all pulling it down. Okay, so forces that are equal but act in opposite directions are balanced. And if an object has balanced forces acting on it, it was going to be stationary or moving at a constant velocity. So what happens if a forward force is larger than the backward force? Well, in that case, our object is going to accelerate. Okay, so to find the resultant force on an object, you need to add any forces that are acting in the same direction and subtract any forces that are acting in opposite directions. So if we look at the top example here, we've got 5 and 4 both acting in the same direction, so that gives us a resultant force of 9 newtons acting in that direction. Our second example, we've got 4 and 6, but they're in opposite directions, so we subtract, which gives us 2 acting in the direction of the larger force. Okay. Pause the video for a minute, have a go at copying and completing this. Okay, so when more than one force acts on an object, we can combine the forces into a single force, which we call the resultant force. If the forces are in the same direction, we add them together. If they act in opposite directions, then we subtract them. Okay, so what's going to happen if we've got unbalanced forces? Well, let's have a look at this example. Let's see what forces are acting on it first of all. We've got 5 newtons acting to the left, another 5 newtons acting to the left, and 15 newtons acting to the right. So the resultant force acting on that is going to be 5 newtons to the right, because 15 minus 10 is 5. Okay, so what's going to happen if there's 5 newtons acting to the right as the resultant force? That means it's going to accelerate towards the right. So if the resultant force on the object is not 0, then it's going to accelerate in the direction of the resultant force. If the resultant force is 0, then it's going to be stationary or moving at constant velocity, depending on how it started out. If we have a look at that in the form of a table, let's have a look. If you've got a stationary object and there's no resultant force on it, it stays still. If there is a resultant force, if the resultant force is not equal to 0, it starts moving. If our object is moving to begin with and there is 0 resultant force on it, then it stays moving at the same velocity. If the resultant force is not 0, then it accelerates or decelerates. Okay, so what I'd like you to do is I'd like you to draw a cyclist that's stationary, then accelerating with a forward force of 100 newtons, then reach top speed with a forward force still 100 newtons. So pause, have a go at answering these, and then we will go through the answers. Okay, so for stationary, you should have your dot for the cyclist, and then we've got weight acting downwards, and we've got our normal contact force, because remember our cyclist is in contact with the ground, and any two surfaces in contact have a normal contact force between them, and that's acting upwards, but there's no forwards or backward forces if it's stationary, so the resultant force acting on it is 0. Okay, our second question has it accelerating with a forward force of 100 newtons. So again, dot for our cyclist. We've again got the weight acting downwards, and we've got the normal contact force acting upwards. This time, we've also got a forward force of 100 newtons that's going to be acting, we'll say, to the right. It doesn't matter if you did it to the left, it just depends on where you decided forward was. And I'm going to say it's just started accelerating, so there's no air resistance. That gives us a resultant force of 100 newtons in the forward direction. Question 3 It's reached a top speed, and the forward force is still 100 newtons. So again, we've got the normal contact force acting upwards and the weight acting downwards. They cancel each other out, so we don't need to consider them any further. Then we've got our forward force, our thrust of 100 newtons going to the right. Because it's a constant velocity, we know the forces must be balanced, so there must also be air resistance of 100 newtons acting backwards. Why has he reached the top speed? Well, he's reached top speed because the forces acting are balanced. Okay, the forward force is equal to the backward force. That means the resultant force is going to be 0, and therefore there's 0 acceleration. So he's staying at a constant speed. Okay, if you do higher tier, you need to be able to resolve forces. That's breaking a force that's not horizontal or vertical down into its vertical and horizontal components. So we do that using trigonometry. You might in maths have studied SOHCAHTOA already, SOHCAHTOA. Okay, the SOH tells us that sine of 40 is equal to the opposite, so it's the side opposite to the angle, divided by the hypotenuse, which is the long side. The cap bit says us the cos of the angle is equal to the side adjacent to or next to the angle, divided by the hypotenuse. So those are the two that we want to look at. If we want to find the vertical component, we're going to use sine because the vertical is opposite to the angle. If we want to find the horizontal, we're going to use cos because it's adjacent to the angle. Okay, for higher tier also, you need to know about inertia, and inertia is defined as the tendency of objects to continue in their state of rest or constant velocity. It takes a force to overcome the inertia of an object, so if you want to change the motion of something, you need a force. Right, have a go at answering these plenary questions. Pause the video a moment and then we'll go through them. Okay, for question C, you need to say that it will accelerate. For BA, the forward force is bigger than the backward force in your diagram. For part B, you needed the two forces to be equal in size, and for part C, you needed the backward force to be larger than the forward force. Okay, have a go at the questions that I've set you on fronter and see.